let's talk about enzymes and what they are. Enzymes are a type of protein which help speed up reactions. So they're a type of biological catalyst. Okay. And this basically speeds up a reaction. It doesn't allow for a reaction to be created. So if something normally doesn't take place, it doesn't allow for that, but it speeds up this reaction. So for example, if you needed to go to the grocery store, you can run, but going in your car might be faster. So you eventually will still get there, but you'll get there at a faster rate if you use your car. So this is similar to how an enzyme works. It just increases the rate or the speed at which a biological reaction takes place. An enzyme is also never used up. So these enzymes are recycled and reused multiple times, and they don't completely disappear. Also, in order for enzymes to work, they need something called a substrate. A substrate is needed to activate the enzyme, and it's identified chemically. It binds at the activation site, and this scenario is commonly referred to as the lock and key model, or that's the common representation of the enzyme binding to the substrate. So I'm going to try my best to draw an enzyme here. So for example, let's just think that this is our enzyme here. And as you can see, they can be crazy shapes and different. Enzymes have something called the activation site, which is right here. So activation site. This is where the substrate binds with the enzyme. So in this case, for this particular enzyme to be activated, we need a substrate that actually fits in. So for that to happen, it needs to be able to bind to this activation site. And yeah, that's only possible if you have the right substrate. So in the lock and key model, this would be similar to that of the key and the enzyme being the lock. Enzymes reduce the activation energy, or the amount of energy that's required in order for a certain reaction to take place. That's why they speed them up. So let me show you how that is on a graph. Let's say this is the amount of energy. This is time. We'll say that in the beginning, the reaction has this much energy, but it needs to increase in order for it to continue and actually have a successful reaction, and then it drops and the energy gets stabilized right here. So this is where your reaction is complete. So this is the end, this is the start, and the peak right here is the activation energy. This is the amount of energy that is necessary for the reaction to take place. An enzyme, on the other hand, reduces the activation energy, helping to speed up the process, since the reaction or the reactants don't need to reach this high level of energy. So instead, an enzyme would maybe take this path, reducing the amount of activation energy needed. So this is the new activation energy, and as you can see, it's obviously way less. Enzymes can also be denatured or damaged, and that happens if the temperature is too high, so too high of a temperature, or if the environment of the body is too acidic or too basic. And If it is too acidic or too basic, it will cause, or if the body has a abnormally high temperature, it will cause the enzyme to be denatured or misfolded. So this isn't good for the workings of the enzyme. In order for it to work at the optimal condition, the body temperature must be at 98.6 degrees Fahrenheit, and the pH must be around 8 in order for it to work at optimal conditions. If it doesn't meet these requirements, then it might not work at its fastest rate. The concentration of enzyme also makes a difference. The higher the concentration, the more faster it's able to complete the reaction. If there's a lower concentration of enzyme, then there will be a lower rate at which the reaction is complete. The concentration affects the rate of the reaction since it is able to bind to more substrate.